So children, so we have learned that the electrons will be added to a new shell, hence the atomic size increases down the group, isn't it? So now let us see the other properties. So now ionic radius, and then coming to ionization energy. What is ionization energy? The energy required to pull off the electron. So if you see along the period, the ionization energy keeps on increasing. That means the elements have a tendency to accept electron rather than give an electron. So that's why, as we learned, on the left side, these are electropositive metals. That means they readily give. So that's why the charge is +1 and +2. But as we go on to the right side, the charge gradually becomes a negative, electronegative. That is -3, -2, -1. Indicating what? That they have a tendency to accept electrons. Okay children. So now just let us see other gradations. So now the electronegativity. What is electronegativity? Electronegativity is the tendency to gain electron. So electronegativity increases along the period but decreases down the group because they have a tendency to give. And why they have a tendency to give? Because the nuclear force of attraction is very less, so they can readily lose. But here the nuclear force of attraction is very high, hence they have a tendency to gain. Then similarly, talk about the metallic character. The metallic character decreases along the period. So on my left side, all the elements are metals by nature. On to the right side, elements become non-metallic by nature. Then similarly, the non-metallic character decreases down the group. So that's why the highly metallic element is francium, and also the largest element is francium, okay, as it lies at the bottom of the group 1. Then coming to your as we said, the metallic character is increasing. Clear children? So now coming to the number of shells. Number of shells remains same along the period, but number of shells keep on increasing down the group. So these are some of the gradations. Now just let us talk what were the merits of this periodic table. It was, as we said, based on atomic number. So it was related to their electronic configuration, the position of elements. So hence the properties also showed a regular variation at regular intervals. And it is also easy to remember and understand, because if you know the valency and the valence configuration, then you can automatically understand to which group it belongs and what could be its chemical properties. But then it also has its own drawbacks, and the three main drawbacks are: first, hydrogen position is also still not justified clearly. Then it cannot accommodate the inner transition elements, that is lanthanides and actinides. That's why they are placed at the bottom. Then they are not according to the electronic configuration. If you remember the D block elements, chromium and copper, their electronic configurations have been disturbed, isn't it? So these are the major drawbacks. So with this we end up with the chapter, children. Hope you are clear with that. Okay children, thank you. Have a good day.